Good morning all. Today we'll discuss about real numbers. That is chapter number 1 of 10th class mathematics. In class 9 we have studied some real world real numbers and encountered irrational numbers. And what is real number? Real numbers are the set of all possible numbers that can be represented on a continuous infinite number line including rational numbers. Rational number means integers, fractions, repeating decimals, terminating decimals, and irrational numbers. Irrational numbers are non-repeating, non-terminating decimals. And this real number is denoted by capital R. ठीक है? So in this chapter, we mainly learn the two formulas. That this Euclid division algorithm and fundamental theorem of algorithm. And what Euclid's division algorithm says is it has to do with the divisibility of the integers. Stated simply, it says any positive integers a can be divided by another positive integer b in such a way that it leaves a remainder r that is smaller than b. So many of you probably recognize this as the usual long division process. Although this result is quite easy to state and understand, it has many applications related to divisibility properties of integers. And mainly use of this Euclid division formula is computation of HCF of the two positive integers. Now coming to the fundamental theorem of arithmetics. Fundamental theorem of arithmetics. It has to do with something with the multiplication of the positive integers. You already know that every composite number can be expressed as product of prime in a unique way. Let us take one composite number 6. It can be written as 3 multiply 2 multiply 3. So 2 is a prime number, 3 is also prime number like that. That 6 is the composite number. And this fundamental theorem of arithmetic is used in very deep and significant application in the field of mathematics. So, and we use fundamental theorem of arithmetic for two main application. First, we use it to prove the irrationality of many of the numbers that you are studying in class 9, such as root 2, root 3, root 5. Second, we apply this theorem to explore the exactly the decimal expansion of rational numbers, say p by q form, where q is not equal to 0, is terminating and it is non-terminating repeating. We do so by looking at the prime factorization of denominator q of p by q. And we will use, you will see the prime factorization of q will completely reveal the nature of the decimal expansion of p by q. Chico, let's begin our exploration. The fundamental theorem of arithmetic. In earlier classes, we've seen that natural number can be written as product of prime factors. For example, 2 equal to 2 and again 4 equal to 2 multiply 2 here. and 253 equal to 11 multiplied by 23, so on. That means these are the composite number which can be factorized as prime factor. Here 11 and 23 is a prime numbers. And another, take any collection of prime numbers, say 2, 3, 7, 11 and 23. And if you multiply some or all of these, allowing them to repeat as many times as you wish. So some of the example you see 7 multiply 11 multiply 23, that will give 1771. And another example 3 multiply 7 multiply 11 multiply 23, that will give 5313. And some more examples like this one and this one. Here is a big number is that 32,760. If you factorize with the 2 with this number, factorize divide, you will get the 16,380. This number. Again, you factorize this, you will get 8,000. So keep on going, and it will end up with this number 13 last. So this 2, 2, 2, 3, 3, 3, 7, 13. These are the factors are for this complete expression. So these factors you write as 2 multiply this one as product of primes. That is, because 2 is repeating 3 times, you can write 2 power 3. 3 is repeating 2 times, so 3 power 2. 5 multiply 7, 13 as a product of power of factors. So instead of writing single numbers in multiple way, you write it, use the power of primes. Okay, there are some more examples. And one more thing, this theorem 1.1 fundamental theorem of arithmetic, this will the explanation will definition will come in board exams. So you have to learn this one. So every composite number can be expressed or factorized as product of prime numbers. And this factorization is unique apart from the order in which prime factor occurs. So you have to bear this. Important. So here some detail about the mathematician called Frederick Gauss, and fundamental theorem of arithmetic says that every composite number can be factorized as product of prime. Actually, it says more. It says given any composite number can be factorized as product of prime number in unique way, except for the order in which the prime occurs. That is, given any composite number, there is one and only one way to write as a product of prime, as long as we are not particular about the order in which prime occur. So, example, we regard 2 multiply 3 multiply 5 multiply 7 same as 3 multiply 5 multiply 7 multiply 2, or any other possible order in which this prime can are written. This fact also in the following form. The prime factorization of natural number is unique except for the order of its factors. Here is the important point. In general, composite number x, we factor it as x equal to p1 p2 dash 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 pn, where p1 comma p2 are the prime and written in the ascending order. Okay? So if you combine the same primes, we'll get the power of prime. For example, that what you factor this number na? So these are the factors. So you are writing ascending order. So 2, 3, 5, 7, 13 like this. One here one more example. Example 1. Consider the number 4 power n where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. Did you understand what is the question is? So they are asking 4 power ends with digit 0 when at what value of the n. So let's check. So we have 4 power n. Suppose n equal to 1, we will get 4. When n equal to 2, you will get 16. When n equal to 3, 16 4 ja 64. So this is a repeating number. So here when n is 1, the digit coming at the ones place is 4. When n is 2, it is ending with 6. When n is 3, it is ending with 3. So you can see these are the repeating. 4 power 4 means again 6. So from this what you can say is, if the 4 power n for any value n, we end at digit with a digit 0, then it would be divisible by 5. If 4 power n solution ends with digit 0, it should divisible by 5. So that is prime factorization of 4 would be contain prime number. But this is not possible because 4 power n equal to 2 2 whole power 2 power n. So only factor in this factorization of formula is 2 only. Only 2 is a factor. So the uniqueness of the fundamental theorem about the guarantee that there are no other primes in the factor of 4n. So there is no natural number n for which 4 power n ends with the digit 0. Now let us compute the LCM and HCM of 6 and 20 by prime factorization method. So we have 6 equal to 2 multiply 3, then 20 2 multiply 2 multiply into 5. It is 2 power 4, 2 power 2 multiply 5. Here HCF equal to 2. So highest common multiplying factor is in both sides it is 2 only, both numbers, and LCM is least common multiply. So 2 into 2, this 2, then this 2. Then here 3 is there, 3 is there, 5 is there, 5 is there. So 60. So you here note that HCF is equal to and LCM equal to 2 into 2 power 2 multiply 3 multiplied 5. So here relation between HCM and LCM when there are, if you know the two numbers. two positive integers a and b. So HCF multiply LCM of these two number equal to same numbers a and b should multiply. See here 60 multiply HCF 2, you get 120. ठीक है, and numbers are 60 multiplied another number, two number, sorry, 20 multiplied other another number is 6, you'll get 120. So when there are two positive integers a and b, their LCM and LCM HCM should multiply with HCF. Similarly, find the example 3. Find the HCF of 96 404 by prime factors method. Hence, find the LCM. So, prime factorization of 96 is 2 power 5 multiplied 6, and 404 equal to 2 power 2 into 101. So, HCF of these two integers is 4 power 2 power 2 equal to 4. So this you have found the HCF, and there are the two numbers by HCF LCF formula. You can get the LCM. See LCM multiply HCF equal to two numbers. Let us say A and B. You know the numbers, two numbers, and you know the HCF, so you can find the LCM. So this is the similarly example 4. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. 6 can be written as 3 multiplied by 2. 72 can be written as 2 power 3 multiply 3 power 2. 120 can be written as 2 power 3 multiply 3 into 5. So here HCF equal to, so what is the highest common multiplier? In each case 2 and 3. So 2 into 3 6. So 2 power 3, 3 power 2 and 5 are the greatest power of prime factors 2, 3, 5 respectively, involving 3 numbers. So LCM is 2 power 3, 3 power 2 into 5, 360. Note, 6 into 72 into 120 not equal to HCF and LCM. So product of three numbers is not equal to product of their LCM. When there are three numbers, it is not possible. It is possible when there are only two positive integers a and b. So by using this method, you can factorize 140, 156, this question, this question, this question, this question. If you have any doubt, you can comment me in the section. I'll reply. The second question is to find the LCM and HCF of the given numbers and verify that LCM multiply is equal to product of their numbers or not. You have to verify, find the LCM and then verify. Third question, LCM and HCM of the following is applying the prime factorization method. Just now you did not, the same way you do it. Here, question number 4. Given that HCF is 9 and LCM you have to find, and there are two numbers. So LCM multiplied HCF equal to A into B. You know the numbers A and B. You know the HCF. Find the LCM for this question. And check whether 6 power n can end with the digit 0 for any natural number. In the previously we have discussed 4 power n. Similarly, you do it. Okay? And explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 are composite numbers. Take out the common numbers. Here 13 and 13 is common. Then you will get one expression. Here 5 and 5 is a common. Then you prove it. Another question. There is a circular path around a sport field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the starting point and the same time, go in the same direction. After how many minutes they will meet again at the starting point? Do the HCF. Find the HCF. ठीक है? Revisiting the irrational numbers. In class 9, and you are introduced to the irrational number and many of their properties and studied their existence and how rational and irrational together made a real number. You even studied how to locate the irrational on the number line. However, you did not prove they were irrational. So in this section, we will prove that root 2, root 5, root 3 in general, root power p is a irrational where p is a prime number. One of the theorems you use is fundamental theorem of arithmetics. So recall number s is a irrational. It cannot be written in the form of p by q, where p and q are integers, where q is not equal to 0. Some examples are irrational numbers with which you are already familiar. Root 2, root 3, root 15 pi minus root 2 by 3, point 1 at 1, 1, 1 dash dash etc. Before you prove that root is irrational, we need the following theorem, whose proof is based on fundamental theorem. This theorem is not exam point of view, but you should know before proving any root 2, root 3 is irrational number. So there it is used. So let p be a prime number. If p divides a square, then p divides a also, where a is a integer number. Like this, p divides a square. P divides a square. So then a, p also divides a. So this is a some proof. So here they are consider a equal to p1 into p2, this one, are prime, not necessarily distinct. Therefore a square is multiply of these numbers. So you will get p1 square, p2 square, p power dash 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 p square n. Now we are given that p divides a square. Therefore, from the fundamental theorem of arithmetic, it follows that p is one of the prime factor of a square. However, using the uniqueness of part of the fundamental theorem, we realize that only prime factors of a squares are p1, p2, dash dash pn. So p is one of the p1, p2. Now since a equal to p1, p2 and p divides a, now we are ready with the proof that You have to prove this root is irrational by technique called proof of contradiction. This is very important questions. You will get at least for 5 marks in the board exams. So if you learn any root 2 or root 3, root 4, root 5, root 7, so only you have to learn this, so you can do it any problem. Here, root theorem 1.3, root is irrational. So contradiction, by proof of contradiction, you have to assume that root 2 is a rational number. Okay. If it is a rational, then you should write in the P by Q form. So that you written R by S. So where suppose R and S are common factors other than 1, then we divide the common factor to get root 2 A by B. So where A and B are co-primes. Co-prime means there should be only one as the common factor. This is very important. Co-primes. So by simplifying this, root 2 equal to A by B cross multiply. So you'll get this one B root 2 A. Squaring both side and rearranging, you will get 2b square equal to a square. Therefore 2 divides a square. By theorem 1.2, it follows 2 also divides a. So you can write a equal to 2c. ठीक है, where some integer c, and put this a equal to c in the this equation. So you will get 2b square equal to a square. In the place of a square, you write this one 4c square, because a is equal to c, so 4c will come. So from here 2b square equal to 2c square. So this means 2 divides the b square from this. So 2 also divide b, assuming theorem 1.2 with p equal to 2. Therefore a and b have at least 2 as the common factor. But this contradicts the fact that a and b have no common factor other than 2, because a and b are co-primes. So this contradiction has arises because of the our incorrect assumption that root 2 is a root 2 is irrational. So we conclude that root is irrational. Sorry, we conclude the root is irrational. Similarly, you can prove the example 5, which state prove that root 3 is irrational. So let us assume to the contrary that root is irrational. You have to assume the root is rational. If it is a rational, then you should write root 3 equal to a by b in the p by q form. And here a and b have common factor other than 1. So you can divide by common factor assuming that a and b co-primes. So b root 3 equal to a. Squaring both sides and rearranging, you will get 3b square equal to a square. Here a square is divisible by 3, and by theorem 1.2 it also state that a is also divisible by 3. So a, you can write a equal to 3c, where integer is c. Substituting a equal to 3c in this formula, 3b square equal to a square. So in place of a you write 3c, then you will get 9c square. So b square equal to you'll get 3c square. So here b square is also divisible by 3. See, b square by 3 equal to c square. So b square is divisible 3. So by using theorem 1.2, b is also divisible by 3. And therefore a and b are at least 3 as a common factor. But this contradicts the fact that a and b are co-primes. This contradiction has arises because of our incorrect assumption that root 3 is a rational. So you conclude that root 3 is a irrational. So these irrational form questions, very very important questions. So it will come at least 3 marks or at least 5 marks. From this chapter, you will get at least 3 to 4 marks or 5 to 6 marks. Another important questions. Example 6. 5 minus root 3 is a irrational number. So let us assume to the contrary that is a rational. If it is a rational, then it should be in the form of a by b. So rearranging, you write this root 3 equal to 5 minus a by b. So here and you root 3 equal to 5 minus a by b equal, you can this a, this can be written as 5 b minus a by a. Since a and b are integers, we get 5 minus a by is irrational. So root 3 is also rational as per this. But this contradicts the fact that root 3 is irrational. You know the actual that root 3 is irrational. So in the same expression, a rational number cannot be equal to irrational. If it is a rational number, it should be a rational number. But one should be rational number, another should not be irrational. So this contradiction arises because of our incorrect assumption that root 3 is a rational. So we conclude that 5 minus is irrational. Now example 7. Show that 3 root 2 is rational number. For every question, this kind of questions, you should assume this number is rational. So here 3 root 2 is rational. If you are assuming it is rational, then it should be in the form of a by b and p by q form, where b should not be equal to 0. So rearranging, you will get root 2 equal to a by 3b. Since 3ab are integers, so a by 3b is also rational. So root 2 is also rational as per this. Is it possible to equalize rational and irrational at a time? No. So this contradicts the fact that root 2 is irrational. So we conclude that 3 root is irrational. Exercise 1.2. Prove that root 5 is irrational. Refer above any this one. Example 5. And prove that 3 plus 2 root 5 is irrational. For this also you refer above example. this example number 6. Example number 6. Procedure is same, and here also this, for this question also, this question also, this question. Example 6, here same thing like this only. Summary. In this chapter we have studied the following points. One is fundamental theorem of arithmetics. Every composite can be expressed factorized as product of prime, and this factorization is unique apart from the order in which prime factor occur. If p is a prime, p divides a square, then p divides a, where a is a positive integer. To prove, that root 2 irrational numbers, that we have proved. And note to the reader: the HCF of three numbers PQR multiplied LCM of PQR not equal to multiplication of these numbers, product of these three numbers. But this can happen like this. So just synopsis. What is a real number? A real number is any number that can be represented on a number line or by infinite decimal expansion. So see here, this is the number line. So we have placed 0 here. We place root 2, then pi, some digits 8. Here minus that 7 by 3 minus 5. So this real number means it will have rational numbers, integers, whole numbers, irrational number, everything. ठीक है, it is union of rational numbers and irrational numbers. So if this is the real numbers chapter, if you have any doubt, please write your doubt in the comments. So I will answer everything. And if you do not understand anything, kindly message me. So we'll clarify it. So our motto is to help the poor student who are not able to get the good marks in the mathematics. So we'll help the student to come out this problem, because 10th class is such a, you'll have lot of information to gather and lot of material to study. So don't worry, we'll help you. So if you like this video, kindly subscribe, share. Thank you very much. Okay, I hope you like our videos. In 1 2 days we'll post another 1 2 videos regarding the, and we have done the polynomials also. Next then we'll do the quadratic equations. Thank you for the watching.